Good morning, folks. Today we are going to do some review of right triangle trig. This is stuff that you did a while ago, probably back in geometry, depending on what school you were in before and whatnot. So I do want to review this because this is basically the foundation of a lot of the trig that we're going to be doing. So our whole second semester is not the whole semester, but the majority of it is dedicated to trigonometry. There's a lot of stuff we're going to be doing, and this is just like the cornerstone of a lot of different things that we're going to be doing, but it's essential that you understand this stuff. So this should all be review for you. Like I said, we'll get into more as we go. I'll talk more about the class when I see you next time, but I wanted to just get right into it and start doing some review. So if you remember way back when you learned about trig, and you learned that, well, we use right triangles when we do it. And so if you have a right triangle, right, you have your right angle. You know the other two angles have to add up to 90 degrees because the sum of the angles of a triangle are 180. And when we reference a triangle, when we name it, we name the vertices with capital letters, and we name the sides with lowercase letters, and we typically use the side across from the vertex is labeled with the same letter. So since this vertex has a capital A, the side across from it, which is this side down here, would be lowercase a. Okay, so this would be lowercase b, and this would be lowercase c. And so from that should look familiar because if you remember Pythagorean theorem, so I'll just abbreviate Pythag. Pythagorean theorem says, well, if you square the sides or the legs and add them together, that's going to equal the square of the hypotenuse. Okay, so that's just the general notation having to do with right triangles. But let's get into the whole idea of right triangle trig. All right triangle trig is, and I'll put it in very basic terms, all it is a representation of the ratios of the sides in reference to an angle. Okay, and that probably sounds like a mouthful, but we'll go through it. So I'm sure you've seen this before, SOHCAHTOA, and you're probably like, oh yeah, I remember that. All these do is help you remember the relationships or the ratios between the sides, and then we have a name for each of those ratios. So this would be the sine, this is sine, this is cosine, and I'm abbreviating, and this is tangent. Okay? And sine says that I can take the sine of an angle. It doesn't matter what the angle is. The sine of angle y, okay, doesn't matter what the angle is the ratio of the side opposite the angle over the hypotenuse of the triangle. Okay, the cosine of angle, we'll keep going with angle y, is the ratio of the adjacent side over the hypotenuse, and the tangent of angle y is the ratio of the opposite side over the adjacent side. So that's what all those letters stand for. In case you didn't remember, I just wanted to review that really quickly. And so what do I mean in relation to the side? Well, if I have this triangle, so this is my triangle, I'll call this triangle LMN. Okay, that's my right triangle, and my sides are lengths 3, 4, and 5. So when I'm referring to these, let's say I'm talking about angle, it doesn't really matter. Let's say I'm talking about the sine of angle L. I shouldn't say it doesn't really matter. We only do these ratios on the acute angles, not on the right angle. Okay, that's a different animal. We'll get into that eventually. But we only do it on the acute angles. And so if I say, okay, well, the sine of L, so in relation to angle L, I'm looking for the opposite side over, which is 4, over the hypotenuse, which is always across from your right angle, so that's 5. So the sine of angle L is 4 over 5. Okay, the cosine of angle L, so in relation to angle L, I'm looking for the adjacent side to angle L, which is 3, over the hypotenuse, which is 5. And if I did the tangent of angle L, tangent is in relation to angle L, the opposite over the adjacent, so that would be 4/3. Okay, similarly, I can do the same thing with angle N. And if I did the sine of angle N, now I'm talking about this angle, angle N, and I'm saying in relation to this angle, what's opposite and what's adjacent? Well, opposite is 3, adjacent would be 4. So sine is going to be 3 over the hypotenuse, which is 5. Let me put this back in a color that is easier to see here. The cosine of angle N is going to be adjacent over hypotenuse, so that's going to be 4/5, and the tangent of angle N is going to be opposite over adjacent, which is going to be 3/4. So you can see here how it all depends on the angle that you're talking about as to what the ratio is going to be. Okay. Another quick thing to note on here is remember that the sine ratio or the cosine ratio of either one of these angles can never be equal to 1, nor can it ever be greater than 1. And the reason for that is because the denominator of the sine ratio and the cosine ratio is the hypotenuse. The hypotenuse has to be the longest side of the triangle. It has to be, by definition. Therefore, the numerator is always going to be smaller than the denominator. Okay, so that's just a quick recap of SOHCAHTOA. So how do we use that in a problem? And you'll be doing some practice problems with this. So let's say, for example, here's my right triangle. And a lot of the angles we use are just, we're going to be using Greek letters. So that is Greek letter theta. And let's say I did this, x and 15. And I asked you to find theta, or excuse me, I asked you to just write whatever ratio you have here. You say, okay, well, that's my angle. I have the adjacent side, I have the hypotenuse, so that would be the cosine of theta is equal to x over 15. Okay, very good. Now, let's talk about what if I had an angle in there. So let's say it wasn't theta. Let's say I told you the angle was 20 degrees. I say, okay, well then you're saying cosine of 20 is equal to x over 15. And now I say, okay, well solve for x. Well, some people make this very complicated and you don't need it to be. All you need to do is if you make this into a ratio, right, and then you have a proportion, you have cosine of 20 over 1 equals x over 15, all you have to do is cross multiply. X is equal to 15 times the cosine of 20, and that you can do in your calculator, and you do it as one straight shot. People sometimes make this more complicated than they need to when you're doing it in your calculator. One thing to make sure before you do any trig problems, press the mode button, which is next to second, and look down. It's about the third one down, and it says radian or degree. Make sure you're in degrees, which mine is. That's one that's highlighted. If you're not, you're going to get the wrong answer. We will get to radians, and we will talk about radians eventually. But make sure you have your calculator in degrees. So if I'm going to do this, I can just do it 15 cosine of 20 and put it, whoops, I think I had something in there before. 15 cosine of 20. If you don't close your parentheses, it's not wrong, but it's good to get in the habit of closing your parentheses. Okay, so it's roughly 14.1 when you round it to the nearest tenth. Okay, so that's how you would do that. Here's another example of something like that. Let's say I gave you this. So here is, oops, here's the triangle. I didn't draw that very well. And let's say I told you that this angle was 10 and this side is 7, and I want you to find x. So I'm asking you, I'm asking you to find x. Now, in relation to this angle, I know the opposite side and the hypotenuse. Those are the two values I have. Since I have opposite and hypotenuse, I'm going to use sine. So I'm going to say, okay, well, the sine of 10 is equal to 7 over x. Again, if you set this up as a proportion, you can just cross multiply. And I tell people not to plug anything in your calculator until the very end. And this is going to hold true for most of all the different types of trig problems that we do throughout the semester. If you start plugging decimals in now, you're going to mess up your answer. Wait till the end to plug everything in. Okay, so I divide both sides by the sine of 10. Divide this by the sine of 10. In my calculator, I can do that. 7 divided by the sine of 10. And enter. And I get x is approximately 40.3. Again, it'll probably tell you what to round to, but for our purposes, I'm just rounding to the nearest tenth. Okay, so those are a couple different types of problems. Same thing would be true with tangent, depending on what side you're given. So if you were given an opposite and an adjacent, you would use tangent, but you would solve it the same way. Let's talk about if you're given a triangle. So you're given a triangle and you're given two sides. Please excuse my bad drawing of my right triangle here. You're given two sides, 7 and, we'll go 7 and 11. And not the angle, but you're asked to find the angle. So here's it, well, find theta. Okay, well, in relation to theta, I have the opposite and I have the adjacent. That means I have to use tangent. So I'm going to say, all right, well, the tangent of theta is equal to 7 over 11. Now, in this problem, this is different than the other ones we did. Our variable is the angle. Okay, our variable is the angle. They could have put an x here, they could have put Greek letter. It doesn't matter what the letter is, but the variable is the angle. So what in fact you're doing in your calculator is this. Tan to the negative 1 of 7 over 11. On your calculator, you'll see above tangent in yellow, it's tan to the negative 1. So you're just going to hit second tan, and then you're just going to do 7 divided by 11. Enter, and it'll give you your angle, 32.5 roughly. Okay, so when you are solving for the angle, you have to use that second key first before you press the trig function. Okay, use that second key first. So those are some examples. There's some homework problems where it says to solve the entire triangle. And all that means is this. If you're given your triangle and you're only given an angle and, let's see, you're given an angle and a side. So let's say you're given this, and let's say I told you that this side was 11. Then you would just start from there. So you'd say, okay, well, it doesn't matter which trig function you use. You need to, well, it does. You can only use either sine or tangent because the side is the opposite side. So let's say you start with tangent. Okay, so I'm going to say the tangent of 20 is 11 over, I'll call that x. If I'm going to call that x, I'll call this side y. I would solve for x, and then you can do sine to solve for y, and you can also find the other angle. So find the sides and find the missing angle using your different trig functions. Okay, that's it, everybody. I'll catch you next time. Take care. Bye-bye.